Hello everybody and welcome to another YouTube video. So in today's video, I'm going to be sharing with you a self-taught developer checklist. Now the point of this checklist is to give you kind of a curriculum or roadmap that you can follow along with as you're on your programming/software engineering journey. There's a lot of items on this list. I've got about 25 or 30 different kind of topics/items to share with you, and I've categorized them into 6 different sections. Now I have some notes in front of me, so if you see me referencing that, it's just so I don't forget what to talk about in this video. Regardless, the 6 sections I have here are general programming, data structures and algorithms, design, tools, databases, and finally, web technologies. Now, with that said, you can actually learn a lot of the stuff that's on this list from the sponsor of this video, which is Algo Expert. Before we get started, I need to thank the sponsor of this video, which is Algo Expert. Algo Expert is the best platform to use for preparing for your software engineering coding interviews and has the highest quality coding interview practice questions. With 155 practice questions, detailed solutions in 9 of the most popular programming languages, a feature-packed browser-based coding environment, extensive test suites, and conceptual overviews and code walkthroughs for each and every problem, Algo Expert is the best resource to use to ace your coding interviews. Algo Expert also has a data structures crash course, coding interview assessments, and a mock interviews feature. I can highly recommend Algo Expert as a former customer myself and now an official instructor on the platform. Get started using Algo Expert today by clicking the link in the description and using the code TechWithTim for a discount on the platform. All right, so the first section I have for you here is what I'm calling general programming. Now, this section kind of has all of the skills and topics related to actually writing code. And anyways, the first item on the list here is going to be programming fundamentals. Now, when I say programming fundamentals, I'm kind of encapsulating all of the skills that are going to be transferable to all different programming languages. So things like how does an if statement work, for loops, while loops, functions, conditions, booleans, arithmetic, variables, all of that stuff that's really basic. It's kind of the stuff you learn in maybe a beginner tutorial, but that's going to carry over to all of the different programming languages and that you just undoubtedly really need to know and you need to know very well. Now, once you've mastered that, the next thing to move on to is object-oriented programming. Now, this is very important, even if the programming language you're using doesn't really support object-oriented programming or doesn't have kind of a good implementation for it. Understanding object-oriented programming is just an important thing as a software engineer, and you're going to be working with technologies, frameworks, and languages that use this in some capacity, and so you need to understand it and know how it works. So the next item I have on this list here is going to be static typing. Now, when I say static typing, really what I'm talking about is understanding the differences between programming languages that are statically typed and that are dynamically typed. If you've only ever worked with programming languages like JavaScript, Python, a bunch of other ones as well, ones that are dynamically typed, then you really are missing a large aspect of programming, which is being very intentional about your data types and really understanding how that data is kind of manipulated through the program and what types you have at each kind of stage of code execution. Now, this is very difficult to explain without actually talking really about what static and dynamically typing are, but just make sure you understand that term and ideally look into or kind of just dabble in one of those languages that are statically typed so you have an appreciation of what that means and kind of the advantages and disadvantages you have in each different type of programming language. Now, the next item I have on this list here is going to be programming paradigms. Now, I won't get into this too much, but there's a lot of different styles of programming. Object-oriented, functional, logical. Those are a few examples. And I would highly recommend you're kind of aware of those different styles and you at least know what style and what paradigm the programming language is that you use mainly. Next, after that, I have asynchronous programming. This is kind of doing things based on events rather than on kind of the clock speed or the clock tick of your processor. So lastly, after asynchronous programming, I have concurrency and parallelism. Now, these could be 2 different topics, but they kind of go hand in hand. Concurrency deals with writing programs that have multiple threads. Parallelism deals with programs that are running in multiple processes. And while you need to understand what a thread is, you need to understand what a process is and how you can actually implement concurrency and parallelism in the different programming languages or technologies that you use. So that is going to wrap up this first section here, general programming. I'll just kind of summarize the topics. I had programming fundamentals, object-oriented programming, static typing, programming paradigms, asynchronous programming, concurrency, and finally, parallelism. So moving on to the next section, which is data structures and algorithms. Now there's a lot of stuff in this section that I could talk about. So I'm going to split it into kind of three subsections and then I will elaborate on those. The first subsection I have here is going to be time complexity analysis. The second is going to be data structures and their implementation. And the last is going to be algorithm analysis and design. Those may seem a little bit intimidating, but just kind of the best way to describe each of those subsections. Anyways, in the first section, which was time complexity analysis, what I'm really referring to is being able to look at a block of code and determine how quick this code is going to run, kind of the relative performance of this code. And with that comes stuff like big O notation, big theta notation, big omega notation, how you actually kind of derive the different time complexity of algorithms, how you look at, say, recursive algorithms and figure out what their time complexity is, and all of the math related to that as well. There's not really a ton of math, but there's kind of a few formulas that you need to know, and that will help you determine what the time complexity of different algorithms are. So I'll kind of leave that section there, and I'll just lastly say that this is super important. A lot of people kind of brush over the importance of this. They think they just need to know it for maybe a test, or they think that, if I can just learn this a little bit and get through my coding interview, I'll be fine. There's actually a lot of situations where you really want to understand this, and where the performance of your code could be, way better or way worse depending on your understanding of these, in my opinion, relatively simple topics once you kind of do enough practice with them. Regardless, let's move on to the next section I had, which is data structures. Now, what I'm going to do is just list out a ton of data structures. There's probably a bunch I'm going to miss, but this will give you kind of a good starting place for learning data structures. All right, so I have arrays, stacks, queues, priority queue, linked list, hash tables. When you're learning about hash tables, you should learn about something like a hash function as well. Then I have trees. That could be something like an AVL tree, a binary tree, binary search tree. B trees? There's B plus trees. There's so many different types of trees, and just kind of the general world of trees you need to know about. Then we have heaps. That would include something like a min heap, a max heap, how you actually implement a heap in terms of, moving items up and moving items down, all of that. And then finally, there's graphs and graph theory. So understanding the different types of graphs, like there's like a bipartite graph, and kind of all of those like words and terms and things related to graphs are pretty important to understand. And then finally, the last thing I threw in here was sets and set theory. It's actually pretty useful to understand set theory, like intersection of sets, differences between sets, and all of that kind of stuff. You can use that a lot to actually optimize your code. And so that'll kind of wrap up the data structure section. There's way better resources than this short video that can kind of tell you where to get started with data structures, but those are a few examples of common ones that you're definitely going to want to know. Then lastly, moving on to algorithm analysis and design. So the reason I put this one last is because you definitely need to know the first two things, so time complexity and data structures, before you can start designing and analyzing algorithms. But this is about being able to look at two algorithms that solve the same problem and figure out which one is going to perform better, right? So that kind of goes with time complexity. It's also being able to create algorithms that can solve problems, understanding approaches like dynamic programming, like solving programs recursively, like using heaps to solve problems, using arrays to solve problems. And it's kind of about taking all this theoretical knowledge and actually applying this into algorithms that use these different data structures, and that you need to do a time complexity analysis on to determine how fast they're going to be running. Now, of course, you can use all kinds of kind of platforms to practice these skills, but in my opinion, it's really important to actually be able to take these very theoretical concepts and apply them into real world problems and real world algorithms. So moving on to the next section here, I have design. Now, when I say design, I'm not referring to UI design or styling or anything like that. I'm talking about how you actually design a program or a system. And so this is being able to be given some type of spec or details of a system and come up with a design that actually is able to implement this system, right? So the design could be in so many different forms. It's very difficult to give specifics here, but something like a UML diagram. This could be something like an activity diagram, a state diagram, maybe a user flow diagram. There's so many different things you could do when it comes to design. And that kind of hits my first point here, which is modeling and documentation. So within this design section, the first thing you should be able to do is kind of model a system, draw out the class diagram for it, come up with the state diagram, the activity diagram. If you don't know what those things are, those are really good things to look up and kind of be familiar with because you'll see them all the time. Now, the next point I have in this design section is design principles. Now, these are things that are just what you want to think about when you're writing code, when you're designing a system. This is more, okay, you can come up with a design, but how good is your design? Does it follow these design principles? And in fact, I have a video discussing 10 design principles. I'll link it somewhere on the screen, but that would elaborate more on this point. Next, or lastly, I have design patterns. So once you've learned the kind of core design principles, you know how to actually, use software maybe to make some type of model for a system, you know how to take a spec and create a design, you want to learn about the design patterns, right? Kind of the common ones that you'll see all of the time. Few examples of this could be like the observer pattern. This could be the subscriber pattern. This could be singleton. This could be decorator. There's a lot of different patterns out there. I'm not going to go through all of them in this video, but they are important to understand or at least kind of be aware of. So when you are designing a system, you can use something that's already kind of proven to work and that already has its listed advantages and disadvantages. Anyways, that'll kind of wrap up the design section. Hard to come up with kind of, unique points to put in here, but you just want to be able to design a system, come up with a model for a system, do a class diagram, understand how to read those diagrams and all of that kind of stuff. So the next section I have here is tools. Now, it's not really much I need to say. These are just tools you need to know as a software engineer. So the first tool I have is Git/version control. Now this is super important. This is like the one that if you're going to pick anything on this list to learn this, like you need to know this 100%. And if you're someone who is kind of putting off learning Git, just go do it. Trust me, it's not that hard. I was like that when I was younger too. I'm like, oh, I don't want to learn Git. I'm like, I'll learn it when I need to learn it. And then I was like, oh, I should have just learned this. It would have taken me like an hour and then I would have known how this stuff works. Regardless, you really need to understand a version control software. The reason I'm not just saying Git, I'm saying version control as well, is because there is some other types of version control software out there, but Git is the most popular. It's used in like almost every project. And so I would highly recommend you learn Git. Now, if you're working in any team environment, this is going to be expected. You're going to have to use Git. You can't really escape it. If you're working alone, you can get away with it. But if you're working on a large project, you're probably going to want to use some type of version control software. Anyways, next tool here I have is Linux. Now, you could argue if this is a tool or not, because this is just an operating system, but it's very important to understand basic Linux commands. Now, I'm not saying you got to go out there and be an expert at Linux and be able to, administer a server or anything like that. I'm just saying that if you were put in a command line environment, you should be able to at least navigate that environment, right? Change directories, look at files, search for something, make a new directory, delete a file, create a file, run a script. Like you should know those basic things. And a lot of people may be like, oh, I don't need to work with Linux. I do this or this. There's a few exceptions where maybe Linux you don't need to know at all. But at least in my scenario, I find a lot of times if I want to host a website or I want to do anything that's kind of on a network, I really need to understand Linux because almost every server is running some type of Linux distribution. Anyways, I would highly recommend it. I have a series on my channel, funny enough, called Linux for Programmers that aims to give you all of the kind of necessary information for programmers looking to learn Linux. Anyways, the next thing I have here is IDEs, Integrated Development Environment. Now, it's fine to use a text editor, and I actually recommend using a text editor for beginners when you're just learning how to code. But as soon as you get into a professional environment, you've got to learn these type of tools, right? Integrated Development Environment. Now, this is something like VS Code, PyCharm, Visual Studio. There's a bunch of other ones as well, and you just want to learn at least one of them and be very familiar with things like the debugger, with how to, refactor code, how to search for stuff in the editor, how to do find and replace, all of that kind of stuff. It'll speed up your workflow a ton. And you just are going to have to use an IDE at some point. So you might as well start learning one. All right, so that's going to wrap up the tools section. Now we're moving on to databases. Now, when I say databases, all I'm trying to tell you is that you should learn a little bit about databases. I don't think you need to be an expert. I don't think you need to be able to design the most scalable, crazy database in the world, but I think it's important to at least understand something like SQL, right? Structured query language. This is something that's not that hard to understand. You could do this in maybe a few days, few weeks, and to be able to read that, understand it, write some basic queries is only going to help you, especially if you're someone who's kind of more on the back end side of development. Then after you learn about structured query language, what you're probably going to want to do is learn a little bit about database design. Nothing crazy, but you want to know how you can do something like relationships between different models, how you can query more efficiently, how you can design your database so you don't have redundant information stored in maybe two different models or something like that. And while I won't go into this too much, but it's just something that I would highly recommend you learn. This is something I never really learned until I was forced to do it in university. And once I did learn it in university, I realized that this is a pretty big asset. It's good to know this type of stuff. And I just feel a lot more confident now when I am working with databases because of that knowledge that I have. All right, so moving on to the last section here, I have web technologies. Now, this is another one that might be a little bit subjective. Some of you guys, maybe you're hardcore C++ programmers and you just make 3D games or something. Okay, sure, don't learn web technologies then. But in my opinion, if you're a developer in 2021, everything's kind of going towards the internet. Everything's going, mobile, web, all that kind of stuff. And so I think it's important to at least understand how the web works on a very surface level. And that's kind of what these topics are designed to do, give you a very surface level understanding of some pretty important kind of core web technology topics. So anyways, the first thing I would recommend you're familiar with is HTTP and HTTP methods. So HTTP is Hypertext Transfer Protocol. So what I mean by this is learn something like a post request, get request, put request, delete request, kind of the basic things behind that. What is a header? What is a response body, a request body? What are query parameters? Those basic kind of things that you actually see like all of the time, but that you maybe just don't actually know about if you've never looked into them. Then the next thing I would recommend learning is about APIs and JSON. Now, some of you may be like, why'd you put APIs and JSON together? Well, APIs typically return JSON data. And so a lot of times when you're writing a program, you're going to be calling an API that's going to return some JSON to you. And so you should probably just know like some of the very basic syntax rules of JSON, not very hard to learn. JSON stands for JavaScript Object Notation. Next, I would recommend learning about the client server kind of architecture or model. This is pretty straightforward, but just what is the difference between a client? What is the difference between a server? How do they communicate with each other using what protocol? HTTP is an example of a protocol, so on and so forth. Hopefully you get the idea there. And then lastly, I would recommend learning just some really basic networking stuff. So understanding like what an IP address is, what's a public IP, what's a local IP, what's the difference between your local network versus the internet in general? How does a router work? This is stuff that you don't need to know, but that for me at least, I find really helpful. And a lot of times I'm kind of reading documentation or working with specifically any type of web framework, this is just good to know. It just makes everything a little bit more clear and gives me kind of a deeper understanding of what's really going on. All right, so with that said, that is going to wrap up this self-taught developer checklist. Now, I apologize if I overwhelmed any of you guys with a ton of different topics here. Again, the idea behind this video is to give you kind of a solid curriculum and learning path, and at minimum, maybe introduce some topics to you hadn't considered learning and that maybe you're going to go out and learn now. And well, if you thought I forgot anything, if you thought some of the topics I said shouldn't have been on this list, please do let me know in the comments down below. I always appreciate your feedback. Anyways, hope you guys enjoyed. If you did, leave a like, subscribe to the channel, and I will see you in another YouTube video.